Right, so now we've talked about types of data and we've talked about sampling techniques. So let's have a look now at actually organizing the data. So, frequency distributions. Is that you, Albert? Yeah, great. Okay. Okay, write that down. So we're going to have a look now at frequency distributions. What does this word mean, frequency?
Like the amount of time.
Yeah. Frequency is how many, how much, how often. That's frequency. And a distribution? Distribution? Any ideas? Yeah, how would you explain this? That would be more like how much of each. Yeah, and you can have them, for example, as percentages or something. So if I said something like, what is the frequency of X, whatever X is, that is the same as asking how many of X are there. In other words, it's like telling the person to count X. Okay? Yeah, can you please make note of that vocabulary? You don't have to write all of this, but I want you to make some note of this vocabulary, this word frequency. Yeah? Yes? Okay. So, when we talk about counting, does anyone know this verb, tally? You know it? What's it mean?
To count down.
Yeah, but it's to count in a certain way.
Like, you draw the line.
Yes.
And then there's 5, you draw.
That's it, that's the one. So, for example, if I said tally, A, B, B, A, B. So this is my first example. So I said, tally this. So can you write this down? This is our first example. Yeah? So if these are students' grades, what type of data is that, students' grades? Quantitative or qualitative? Qualitative. Ordinal or nominal? Ordinal. You can put this in an order. Anyways, tally. What you would do is you'd write down each possibility. A, B, and you start counting. So you go 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And the B would just be 1, 2, 3. So this is a tally. A tally is also a noun. So tally is a verb, and also when you have the result, it is a noun as well. So this is the tally of A and B. And it's also an adjective. So if I said tally man, what's a tally man? What do you think? Have a guess. A wild guess. What do you think I could mean? A tally man.
Old man.
Correct. A man who tallies. So that's a tally man. Yeah. So it's the person who counts here. Now, this is actually a very old word, and nobody really says it anymore, with the exception of maybe in politics when people are counting the votes. You would still call them tally men. Okay. So it's a verb, it's a noun, and it's an adjective as well. Okay. So like you could have something, for example, this here, 1, 2, 3, 4, 5, this is a tally system. And in fact, I think it's different in China. Isn't it? No, let's see if I remember. This first. No. This first, then this, then this, then this, then this. Yes? Is this it? No. Okay. 1. Yes? 2. 3. Yes? 4. No. Too short. 4. Wait, starts here. 4. Okay, 5. This is the Chinese version of that. Yeah. So in China, they don't go 1, 2, 3, 4, 5. They go 1, 2, 3. No. Whatever. No, not whatever. 1, 2, 3, 4, 5 or something. Yeah. Anyways, that's a tally system. Now, I think most of the world uses this. Would that be right? No? What do you use then? Really? Wow, okay, so you start at the top, the bottom, the left, and the right. Which is it? Does it matter? So you go like 1, 2, 3, 4, 5. Wow, okay, great. So these are 3 different tally systems. Yeah, so this is Brazil, this is China, and is this everybody else? Yeah? Yes? Yeah, no other special ones, no. So people in prison in Brazil, when they write on the wall, is it like this? When they, in the movies they count the days. Is it like this, or is it like this? You've never been to prison, no? Okay. So this is a tally system. So for the exam, we use this one, okay? 1, 2, 3, 4, and 5. This is tally. Okay, so for example, I want to do this bit by bit. For example, tally, okay. So if you remember yesterday, we had quantitative continuous, quantitative discrete, qualitative ordinal, and qualitative nominal. So can we use a tally for nominal, like eye colour? Could you use a tally for eye colour? Yeah, you could. For grades, ordinal grades, yes. For discrete data, like shoe size, yeah. But not for continuous data. Okay, so for tally, you can do it for everything except continuous. Now, I just want you to practice. Can you, in question 1, tally the grades in number 1? Tallied. Thank you for not doing a Chinese spell. Good. Okay. So that's tallying. That's pretty easy. Now, that's usually not what we need to do, because the problem with tallying is you don't really have numbers. Okay. So what you can also do with this type of data is tabulate. Does anybody know this verb? Tabulate. Does anyone know this one? I bet you know the noun. Table. So tabulate means to put the data in a table. So let's do an example. Tabulate, let's go with, we'll go with something like eye color. So like you can have like brown, brown, blue, blue, brown, 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 blue, brown, green. So I would say tabulate this data, so this is our next example, into a frequency table. Okay, so write this one down, please. You got the data? Great, okay. Can I scroll down a little bit? Yeah, so first thing you need to do is list out all the possibilities you can have. So for example, in this one, in our eye color, we can have brown, blue, or green. How many browns? 1, 2, 3, 4, 5, 6. How many blue? 1, 2, 3. And green? 1. This is the frequency, so we'll write an F here. And usually, you should also put down the bottom here the total. N. How many you have. And that is, in this case, 10. So you can write total or you can write N for short. This is a frequency table. Now, sometimes they want you to add in the percentages as well. So, percentages. You all know how to calculate percentage, courtesy of your elementary school teacher. So 6 out of 10 is 60%. This one here, blue eyes, 30%, and green eyes, 10%. And the total should always be 100%. There is another name for percentage. This is also called the relative frequency. And this one here is just called the frequency. So if you ever see the word relative frequency, it means percentage. Frequency is how many? Question? You look a little confused. Are you sure? Sure?
I was going to ask you now.
Okay, what were we going to ask? Is it maths related?
Yeah,
Yeah.
it's not the same as cumulative frequency.
No, that's a different thing, yeah, and we'll do that. Yeah, that's right. We'll do that in a different lesson. So what I want you to practice for this one, let's see, you could do like number 4. In number 4, I want a frequency and the percentage. Okay, nearly have that one finished? Yeah. How many men were there and how many women? 12, 18. So as a percentage, let's have a look at the table here. Male, female, and this is gender. And you should have here frequency and percentage, and down here is the total. So I know it's 100%. How many men? 12 and 18. So this one here, let me see, it's 12 over, the total here is 30, isn't it? Yeah, so it's 12 over 30, which is what's that, 6 over 15, 3 over 5. 60%? 60%?
No, 40%.
What? 12 over 30, 6 over 15, 3 over 5.
2 over 5.
2 over 5, thank you. 40 and 60%. Okay. So this is, again, useful for all the data except for continuous. So what do we do with an example like continuous? So, for example, well actually maybe I'll make up some data. I'll put it in a table here. What type of data is continuous? What examples did we have yesterday for continuous data? Height is continuous. So we can't really use this method for tabulating continuous data because what would be the problem?
You can't have value in between.
Yeah, but what would be the problem? Why couldn't I use a table like this for height? Huh?
You will have many students.
Yeah. There's a good chance that everybody's height in this room is different. So if I put this in a table, I'll have height 1, height 1, height 1. Everybody, there'll be one of everything. This is useless. Because when you want to tabulate data, you want to sort of put it together and make less, summarize it. So any ideas what we could do for continuous data? What we could do?
Mean average, model.
But how to put in a table? Yeah, somebody I think said it. You can group them together. So you could say how many people are between this height and this height, and between this height and this height here. So we'll make up some heights, for example. So let's say here's our data. Can you see this okay? No, that's tiny. Can you see this okay? Yeah. We'll make up 10 heights. So we'll say, 151, 155, 159, 160, 152. I want to make them all different. 158. We'll make two of them the same. 161 and 200. No, 163. Yeah. Oh, that's not 10. 162. Okay, so this is our data. So can you just write this down, please? Yeah. Okay. You got all of that? Yeah? Right, so the first thing you want to do, if you're going to put it into a table, you need to decide how many groups you should have. So here I have 10, so of course I shouldn't have 10 groups because that's ridiculous. That means everybody has their own group nearly. So does anybody know how many groups we should have? 2, 4, like, is there any way to know how many groups we should have? The number of groupings?
Usually it's 4.
No, it could be different. So what do you think? 3 maybe? So there is a way. What you can do is you can calculate the square root of how many you have. So the square root of 10. So I'll just type that in here. Square root of 10. That's 3.16. And then you always round up. So here you would get 4. So for this data I should use 4 groups. Now in fact the reason I'm telling you this is because a lot of software that does this automatically, how does it know how many groups to make? So it'll be, some method like this. So this is the best number of groups to use. Less than 4 is not enough, and more than 4 is too many. So 4 is the best number here. Can you make note of how I got that? Okay, so let me just check something here. 1.65. 1.4. Okay, yeah. Now, again, well not again, but I should say, this is only a guideline. It's not like a rule. It's not like you have to do this, It's just an idea, a rule, a rough way to know how many groups you should use. But it's not a rule. If you did 5 boxes in the exam, I'll still give you the marks. And if you did 3 boxes in the exam, that's fine also. Okay? But if you did something like 10 boxes, no way. And if you did 1 box, definitely not. Okay? Right, so we know that we should have 4 boxes, 4 groups. So let me just separate out 4 of them. So if I can, maybe if I can highlight these 4 here. How do I do that? No, I didn't do it. Font color black. No good. We want to at least make it a kind of a grey colour. That'll do. My lines have disappeared now though. Oh well. You can imagine the box is still there. So we know that we should have 4. So on the top row is the group. So for example, don't write this part down. You would write where the group starts and where it ends. And you would do that 4 times. So the next thing we need to do is work out where to start and where to end. Now, where this group ends should be where the next group starts. Otherwise, you'll miss some values. So, where do we start? Well, first thing we need to do is work out how big each group needs to be. So, first we need to find out what is the smallest value and what is the biggest value. So what is the smallest data here? This one here is the minimum. And the biggest? Oh, that's handy. 163 is the biggest. So we should first work out something called the range. The range is the biggest number minus the smallest number. That's called the range. Okay, so write this bit down. Got that? Yeah? Okay, so let me just check one thing. So that's 12. Okay. Now, yes. Let me think. I don't want to screw this up or the table will be terrible. 151. Okay. Right. So the next thing you want to do is work out how big each piece needs to be. Now this is what I was double checking. So how big, how wide each piece needs to be. So if I can just zoom out a little bit. Can you still see okay? The next thing is you want is called the class width. And that's how wide each piece should be. Now I don't think, should I use 12 divided by 4? Yes. Yeah, I should start with 12. I don't know about this. 12 divided by 4 is 3. Okay, I hope this works. Right, so the first piece, where should I start?
Did you get the width?
12 is the range, and there's 4 boxes, so I divided by 4 and I got 3. But no, my spider senses are telling me this is going to be a problem later. You think so too? Yes. Let me just picture what's going to happen. So you're going to get there, and there, but we'll miss the last piece. So if I go a little bit to the left, and then make it bigger. Don't write this down until we see if it works, okay? So I think dividing by 4 is a little bit too, it's going to make them a little bit too small. I think we should try and divide it by 3, make it a little bit bigger. So if I do 12 divided by 3, I get 4. Okay. And also, where should I start? I shouldn't start at the minimum. It's not really good to start right at the minimum and finish right at the maximum. What you want to do is start a little to the left of the minimum, and you want to finish a little to the right of the maximum. Now the reason for that, I'll explain in a moment. How big is each piece? It's 4. So if I want to start a little bit to the left, I should start half of this distance to the left. So I should start at 2 away. If the smallest is 151, what's 2 to the left of 151? Yeah, so I'm going to start at 149, and where should I finish if I go up in 4s? I should finish at 153. The next one should start at 153 and finish at, what do you think? 157. The next one should start at 157 and finish at 161. And then the last one should start at 161 and finish at 165. Okay, that's perfect. This number here is the range divided by not 4, but 1 less, 3. So it's the range divided by 4 minus 1. If you use 4, it's a little bit, the size isn't a little bit right. I'll explain now. If I use 4, I would finish at exactly 163. But this is a problem because I have 163. And I never include the endpoints here. Do you remember these brackets, the square and the open? So the round brackets include or not include? Not include. So if I used 4, the problem is I'd finish exactly on 163, and actually then where do I put 163? So what I want to do is start a little to the left of the smallest and finish a little to the right of the biggest. That's what I want to do.
Would be always the number of boxes minus 1?
Yeah.
To calculate the width?
The width. Yeah.
It's always the number of boxes?
That will give you a good size. And also, you should always start at half the width to the left.
Actually, when you have like decimal places, it will be there, huh?
It just gets ugly, that's all. Oh, where did my last one go? 161 to 165. Again, listen, this is not a rule. You don't have to make the table this way. I'm just trying to give you a way to make the table beautiful. Okay? So this will make a very nice table. How many are between 149 and 153, not including 153? Is it just 2? And how many between 153 and 157?
1.
Just 1. And 157 and 161? 4. And then 161 and 165? 3, isn't it? Good, okay. Stuck. Come on, you can do it. There. So, I know this process seems needlessly complicated because you're just making a table. But at the end, look at the table that you have. Each group, each bin, each box, they're all roughly the same size. You know, you have 2, 1, 4, 3. It's not like you had 2, 1, a million and 4. Okay? So what you really want in your table is you want them all to be about the same size. You don't want anything weird like this. This would be a terrible table. 2, 1, 40 and 3. Because that means the 40 you should have broken it up into smaller pieces. Also, we don't start at the minimum and we don't finish at the maximum, so we never have any questions about where the minimum and the maximum should go. Clearly the minimum needs to go in here, and clearly the maximum needs to go in here. We have the right number of boxes, not too many and not too few. So this really, I know it seems silly, but it really is a good procedure for making the table. So just to review it, how did I get the number of boxes? How did I get the number of boxes? The number of bins. Yeah, it's the square root of the n rounded up. You must round it up. Okay. How did I get the width? It's the range divided by n minus 1, the number of bins minus 1. And where do I get my starting point? So you should always start a half the width to the left of the minimum. And if you do this, you can make a very nice table, and the values will be reasonable values as well. So just a little bit of vocabulary. This 149, 153, 157 and 161, they're called the lower boundary. And the 153, 157, 161 and 165 is called the upper boundary. The widths are 4, 4, 4 and 4. Do you need to use the same widths? What do you think? Technically, no. You don't have to use the same widths, but it's recommended. And finally, for this one, we have something called the midpoint. So what do you think the midpoint here is for this class, this boundary? What do you think it means by midpoint? It's literally the number in the middle. Yeah, so here it would be 149 plus 153 divided by 2. So 151. No, 125 is definitely not in the middle of these two numbers. You did something wrong. Now, maybe my table at the back doesn't match your table perfectly. That's fine, okay? It's not like this is the only way to do it and it must be like this. I'm just giving you advice on how to make a table. Yeah. Now, there's one other thing I need to show you before we finish. Make sure you have all of this, please. Did you write it all down? You have all of this? Yeah. Okay, so, let me see. Can I remove all of this? Yeah, okay. Right. And how do I get rid of this? I'll scroll down. Okay, so have a look at this table. And this is a table for how many brothers and sisters you have. So the first bin will be, we'll say, 0 to 1. Well, no, I don't want to do brothers and sisters. Let's do something more interesting. I can't think of anything interesting. I'm just going to call it X. So X could be 0 to 2, and then it could be 3 to 5. Not this. 3 to 5, 6 to 9, is it? We'll do. Well, it doesn't matter. It doesn't have to be the same. And then we'll do, I don't know, 10 to, let's say 15. 10 to 15.
Do you have a problem?
Everything is good.
You know, like 0 to 2 to 5.
Now, so what this means is, if X is 0, 1 or 2, it goes here. If it's 3, 4 or 5, it goes here. If it's 6, 7, 8 or 9, it goes here. And if it's 10, 11, 12, 13, 14 or 15, it goes here.
If it was between 2 and 3.
Yeah, well, this is what we'll get to now. This is exactly it. So let's say F. Let's say 5 people have this, 2 people have this, 3 people have this, and 1 person has this, for example. Now, X could be a decimal number. For example, if X was 1.5, where would it go? First, second, third, or fourth bin? It would go in the first bin, wouldn't it? 1.5. What about 6.1? Third one. What about 5.1? Yeah. Where would that go?
Nowhere.
Must go somewhere. 5.1. The second one. Because 5.1, does it round up to 6 or does it round down to 5? Down to 5. So for example, what this table is missing is it's missing the boundaries. The first boundary starts at 0, but you could go as far as 2.5. But would you include 2.5? No, because 2.5 rounds up. The next one, where does it really begin? It really begins at 2.5 and finishes at 5.5. This one here, 5.5 to 9.5. And this one here, 9.5 to 15.5. Now, some people might say, and you're right if you want to say it, actually it's not really 0, it's minus 0.5. Because if you had minus 0.1, that would round up to 0. But usually in the exam they don't mind. You could start at 0, that's fine. Especially if X represents something that could only be positive, like shoe size or whatever. Can't have negative. Yeah. Now, they like this question in the exam a lot. Of the 19 exam papers or 20 exam papers I have, they asked you to do this 19 times. So nearly 100% of exams, they'll ask you to convert this table into a proper frequency table with the boundaries included. Then they also ask you for the midpoints. So, what would be the first midpoint? it would be 2.5 plus 0 over 2, which is 1.25. The next one, 2.5 plus 5.5 over 2, which is 4. The next one, 5.5 plus 9.5 over 2, which is 7.5. And then the last one is 9.5 plus 15.5 over 2, which is 12.5. These are called the class midpoints. These are called the class boundaries. So again, it's very common in the exam to give you this incomplete table and to ask you for the midpoints and to ask you for the boundaries. Very common. I think you could get something like this. Okay. Now, percentages, they might ask this year, but they usually don't. But they could ask you to make these percentages. What's the word for percentages? Relative frequency. So the first one, how many do I have in total? 11. Is it 5, 6, 7, 8, 9, 11, isn't it? So the first percentage, let me see, would be 45%. The second one would be, let's see, 2 over 11. Oops. 2 over 11, 18%. The next one would be 3 over 11, that's 27%. And the last one, well, it has to be 1 over 11, so it'd be 9%. So there's the relative frequencies for each bin, each class. I know this is because we have to round it, so I suppose, is it more or less than 100? Okay, we'll make the last one 10. 10 plus 27 plus 18 plus 40. Yeah, okay. It's fine actually, it's because of the rounding that it makes not 100.
Thank you.
Okay. Now, yeah. Don't worry, we're finished. It's not going to take you that long to do these, so I would like you to do all of these. You know how to count, so as long as your counting is good, you can do this quickly. What? It does take time. But what else are you going to... Yes, all. What else are you going to do with your time? Yeah? World of Warcraft? Call of Duty? EAP? For real? What's due in EAP? Easy peasy. Alright. I'm very sure.